let's get some practice with the cosine. What does it mean to be an even function? Well, it's the statement that for cosine, cos of minus x or cos of minus theta is equal to cos of theta. So it's a pure statement about the nature of the function. But we do know how to spot, using the graph, if something is even, don't we? So what does it need to have? It needs to have symmetry in a specific way, and the symmetry has to be reflective symmetry across the y-axis. So if I graph cos of theta, what does it look like? Cos of theta looks like this. So I'll do my best to draw it not totally horrid. It's pretty hard to do by hand. Cos of theta looks like that, okay, at least until you get to 2 pi. And then basically the whole thing repeats itself, doesn't it? So it looks kind of like this. Over here looks like this. Dot, dot, dot. So could I have spotted the evenness purely from the graph? Well, absolutely, definitely. You see here, if I was to take this graph and I was to reflect it across the y-axis, it would be exactly the same. Nothing would change. It wouldn't be true of the sine graph, but it's true of the cosine graph. For the sine graph, you could spot that it was that it was an odd function because it would have rotational symmetry about the origin, rotating by pi. But that would make it odd, and this is even, so it has reflective symmetry. So we can see the following. So the graph y is equal to cos theta is the same after reflection in the y-axis. That implies, of course, cosine is an even function. So it's a little bit hand-wavy because we're just looking at a picture, but it's good practice to really understand what the cosine graph looks like.